everyone, this is Miss Reed and this is lesson 4.6. Our objective for today: I can show that pairs of angles or pairs of sides are congruent by identifying related triangles and proving them congruent using CPCTC. In the previous lessons, we discovered 4 shortcuts that show 2 triangles are congruent: side, 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 angle, side, angle, and side, angle, angle. So these 4 work. They're good. So we're going to review those now. Side, side, side. I think it's really helpful to use colors to show how the triangles match up. So I used 3 different colors to show the 3 sides. So there's 3 pairs of congruent sides. Side, angle, side. Notice that the angle is sandwiched in the middle of the 2 sides. Okay, it has to be for this one. And then sides match up. So for this one, it's super important to remember that the angle is between the pair of sides. Angle, side, angle. For this one, the side has to be sandwiched between the 2 angles, which it is. There we go. 2 pairs of congruent angles and 1 pair of congruent sides. The sides are between the pairs of angles. And then side, angle, angle. 2 pairs of congruent angles and 1 pair of congruent sides. Specifically not between the angles. So here the side is not between the angles. It's not in the middle. And then we have a new definition. The definition of congruent triangles states that if 2 triangles are congruent, then the corresponding parts of those congruent triangles are congruent. So C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Example 1. Determine if the triangles are congruent using a congruency shortcut. So first I'm going to write the 4 that I know will work. Side, 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 angle, side. Specifically, that angle has to be sandwiched between the 2 sides. Angle, side, angle, where the side is sandwiched between the 2 angles, or side, angle, angle. And in that one, the side is not between the angles. Alright, so if we look at this example, I see that AM is congruent to BM because of those hash marks. So AM, which is a segment, is congruent to BM, also a line segment. And I know that because it was given to us. So I'm going to write it like I was doing a proof. And that is a side. Just a little note for us. Now looking back at the triangle, I noticed they gave me another mark. This angle here and this angle here. So angle A is congruent to angle B. That was also given to us because of the marks. And that's an angle. And then lastly, if we look, I know that angle 1 and 2 are congruent to each other because they are vertical angles. So angle 1 is congruent to angle 2, vertical angles. And that's an angle. Alright, so we have a side and 2 angles. So it is one of these 2 congruency shortcuts. And if we look, I have angle, side, angle. This side is sandwiched between the angles, so we have angle, side, angle. So I would say yes, these triangles are congruent because of angle, side, angle. So the next part asks us, is AD right here, congruent to BC. Why or why not? Well, we know that the triangles are congruent, so since triangle AMD is congruent to triangle. Now here I would like you to finish filling that part in. I said triangle AMD, so AMD. So you need to figure out how to write the triangle it's congruent to, which way to write the letters, so that all the parts match up. So go ahead and do that right now, please. Alright, so if we look, I wrote AMD, and A matches up with B, so I need to write B, and then M matches up with M, and then D matches up with C. So hopefully you got that right, BMC. And we know they are congruent by angle, side, angle, which we just showed. The triangles are then identical. Which would mean all of their corresponding parts are congruent. So then AD is congruent to BC by CPCTC, which just says the corresponding parts of congruent triangles are congruent. Example 2 is AE congruent to BD. Write a paragraph proof explaining why. So this picture, it looks a little bit confusing to me, so I'm just going to start off with the question they asked me. Is AD congruent to BD? AE is right here, and BD is right here. So I think I just want to focus on this triangle here, and this triangle here, because I need those two sides. So I'm going to redraw this picture by pulling out those two triangles. I drew the two triangles, so now I need to label them. A, D, B, B, E, A. Alright, so remember to write a paragraph proof, I need 3 parts of these two triangles to be congruent. So either side, 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 angle, side, angle, or side, angle, angle. So I wrote that there so we have it to reference. And if this works, if we can prove these two triangles are congruent to each other, then these two side lengths that match up would also be congruent. And that would be using CPCTC. So let's just start by marking up the picture. Use some colors here to help us out. Alright, looking at it, I see that angle D is congruent to angle E because of the 2 hash marks. So angle D is congruent to angle E, and I know that because I was on the picture, so what I write is given. It was given to us, like a lovely gift. What a nice thing. We didn't have to figure that out. Alright, next I notice that this angle here, which is EAB, is congruent to this angle here, DBA. So here and here. Alright, so angle EAB is congruent to angle DBA. And again, we know that because of the marks that were on the original picture, so they gave it to us, it's given. Alright, so I ran out of things that were given to me, so now I have to try to find a third thing that is congruent. Because all of these over here, all of the congruency shortcuts have 3 things congruent. And right now I have 2. So if I look at this original figure here, I can look to see if there's anything that they share. Which if we notice, AB this side length here, they both share it, because right here is AB and here is AB. And we can totally use that. So AB right here. AB is congruent to AB. AB is congruent to AB because it's the same segment. Or you could say the same side. That would work too. Alright, so now we have two angles and a side, and I need you to figure out which of our triangle congruency shortcuts proves that these two triangles are congruent to each other. So it's two angles and a side. Which one is it? Alright, so hopefully you noticed that yes, we have the two angles, but that side is not sandwiched in the middle of them. So we have side, angle, angle. So now I'm going to go ahead and say that the triangles are congruent to each other. So triangle ABD is congruent to triangle what? If I said ABD, how can you write it so that it matches up? Go ahead and do that. Alright, so if I said ABD, ABD, A matches up over here with B, so ABD would be BAE, and you can tell by the color markings that we used. So triangle ABD is congruent to triangle BAE. And we know that by side, angle, angle, which you might see sometimes as angle, angle, side. That's the same thing. Well, we proved them congruent to each other. That's super great, but believe it or not, we're not actually done. If you look back up, the question we were asked, is AE congruent to BD? Well, so now we need to finish out our proof and say that it is. Looking at our picture, AE, BD. We know that they are congruent to each other. AE congruent to BD. But what actually makes them congruent to each other? What do I need to write here to end my proof, showing that they are in fact congruent? Well, if you remember, it's that new thing we learned today. Corresponding parts of congruent triangles are congruent. Again, that says that if you have two triangles that are congruent to each other, all of their corresponding parts, those that match up, are also congruent. So if the triangles are congruent, which here we have shown that the two triangles are congruent by side, angle, angle, then all of the sides that match up, so AE congruent to BD, must also be congruent because of CPCTC. Example 3. Given angle D is congruent to angle C, angle O is congruent to angle A, and angle G is congruent to angle T. Is TA congruent to GO? Explain why or why not. So I'm going to go ahead and start by marking up the figure. They said that D is congruent to C. So angle D is congruent to angle C. Cool. Angle D is congruent to angle C. Off to a great start. How did we know that? They gave it to us. Oh, so nice of them. Alright, next, angle O is congruent to angle A. And use 2 hash marks this time. Angle O is congruent to angle A, and I know that because it was given to us. Great. Next, angle G is congruent to angle T. I'm going to try to do 3 hash marks. 1, 2, 3. 1, 2, 3. So angle G is congruent to angle T. And we know that because it was given. Alright, and we don't have anything else that is congruent with these two triangles, and so we actually just have angle, 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 which if you remember, angle, angle, angle is bad. Bad. But we probably shouldn't just write bad on our tests and when we're trying to be writing a formal proof, so let's make it sound a little bit fancier. So, but triangle TCA may not be congruent to triangle, let's see, TCA, so I should write GDO, because A doesn't show congruency. So this is not enough information. So we say it cannot be determined. Cannot be determined. Cannot be determined. So that's what CNBD means. So there's a formal way to write that AAA is bad. And we're going to save our summary here for a different time and go over that together. So this concludes lesson 4.6.